My name is Dan Baker. I am a solution engineer and I work for MetalBear, who are the creators of an open source tool called MirrorD. And this is actually an interactive workshop. So for anyone who has a laptop, feel free to get it out. The actual workshop part will probably only take 5 or 10 minutes, and I'm going to run through a few slides before we get to the workshop. And I am, for anyone who doesn't have their laptop, I'm going to do the workshop as well on the screen, so you won't miss out. But it is also, I was thinking before, did I vibe code or vibe engineer or prompt engineer this particular workshop over the last few days? But it is the first time that I'm trying it out, so we'll see how we go. So MirrorD is a tool that you use to cut your dev loops from sometimes like hours down to seconds. And so I might just start with a question. Has anyone here ever made a 1 or 2 line change of code and then you've had to wait, say, half an hour or an hour for that code to deploy so that you can see whether or not it worked? Yep, got a bunch of hands there. So pretty common problem, and that's the sort of problem that MirrorD solves. So this isn't going to be news to anyone, but the way that we build and deliver software today is in this like modern distributed architecture where you've got, this is just an example here, we've got a number of services, we've got some databases, message queues, authentication, third-party services, so on and so forth. And there's a lot of good reasons to deliver, software applications and systems in this manner, but there are also some downsides compared to, say, how we built software a number of years ago when it was a little bit more monolithic. And so one of the big downsides is when it comes to testing, like the behavior of the software and being able to do it in a way that is similar to how that software is going to behave in a production-like environment. So obviously, when you're running it on your local machine, there are a number of things you can do, like you can build mocks and stubs, and you can start up a whole range of other services as well. But ultimately, like a critical part of pretty much every developer's software development lifecycle is deploying the application to some sort of remote staging or test environment, and then seeing if your code is actually working as expected in that remote environment. And so looking at this from like a dev loop perspective, especially when you consider the sort of rise of use of agentic coding tools, the inner dev loop, which is kind of there on your left-hand side, that like we can now write code and produce code faster than we ever could before. And whether or not it's like a person writing that code or whether it's an AI agent writing that code, like the point is we can write code really fast now. But then like the ability to test that code, like is it performing what it's supposed to do? Is it performing correctly? That still takes a long time. And generally there's not really like a swath of AI tools that are helping in this area. And MirrorD is not an AI tool either, so you don't have to worry about that. But basically, like the bottleneck is really in that CI/CD deploy phase and like how you're actually going to test that code. And that is the problem that MirrorD solves. So as I already said, it's an open source tool. And what it allows you to do is basically test code in a remote environment, but from your local machine, which doesn't sound like it makes a lot of sense, but actually that is what it does. So you don't actually have to deploy the code in order to test it in that remote environment. And how it actually works is you start like that local service or process on your local machine. You select a remote target pod or container, and MirrorD will pull down like all of the environment variables. It will set up networking between the remote environment and your own so that you can receive requests from that remote environment, send requests back out to the remote environment. It'll also give your local process access to the remote file system. In effect, it feels like your local process is running in that remote remote environment, but it is still running on your local machine. Like if you've got hot reload on your app, you can still make a code change at hot reloads, and you can instantly see like the impact of that in that remote environment. It fits into like your existing applications and dev flows, so you don't have to change your IDE, you don't have to change the way you build your applications. Really, Mirror-D is either just an IDE plugin or a command line tool that you turn on, and you can basically use it to cut down particularly the testing part of your dev loop from sometimes hours down to seconds. Now there is, everything that I just talked about there is like in the open source tool. There is this additional part which is Mirror-D for Teams, and that's really all about allowing larger groups of developers to all test on the same test infrastructure at the same time without breaking the test infrastructure for everyone. But I won't go into too much of that today. And I think I've actually already covered a lot of this. But in this little example here, let's say on our local machine, I've got a React front end there, service A. If I wanted to kind of test some changes in that service on the remote dev environment, I can basically use Mirror-D to start it up. It's going to copy all the environment variables from the remote service A. It's going to give me access to the file system. It's going to give me access to the networking. And I can basically test it out. What's more interesting, and what we're going to do in the little workshop in a sec, is testing like a backend service, and like how can we test the impact of a change in a backend service within that remote test environment. And so, and what we're going to do in the workshop in a sec is set up request stealing, and that's where we're basically going to run service B on our local machine. Where like you're going to use the browser to make a HTTP request to the front end. We're actually going to steal that request as it's supposed to go into the remote version of service B, and we're going to serve that request from our local machine. And what that means is we can actually test like what's the impact of our changes that we're making on service B on the rest of the environment, but without actually deploying to the environment. And so, without further ado, we're going to start the workshop. So for anyone who is not already connected to the Wi-Fi, I'll leave the Wi-Fi details up there for a sec so you can quickly connect, and then head over to that URL and we will get started. So I'll just leave that up there for a minute. And then when I see everyone stop typing, I'll keep going. All right, put your hand up if you still need this page. Okay, yep, there's still two. And then if the password's not working, go ask for the new password. All right, everyone in? Yep. Cool, all right. Let's do it. So we're going to do it together. Oh, this is very small. I've kind of given two pathways for this. One, the fast pathway here is build a little companion app, so you can kind of download the CLI and it will walk you through it a little bit. I'm going to go down through the fast path there. If you kind of want to do it all by hand and copy and paste a bit more stuff from the browser into your terminal, then you can also follow it the manual pathway as well. And it should work. I think everyone's got a Mac here. Actually, no, there's a few people with not Macs. It should work on Windows. It'll work. I've definitely tested it on WSL for Windows. Sorry, and I should like phrase this. Mirror-D will definitely work on Windows, but my little companion app, I've only tested it on WSL, so I haven't tested it on Windows native. It's a Golang app, so I think it will work, but yeah, might have to wait and see. So what we're going to do is we have a front end, and when you load this page initially, you're not going to have this front end, but I've kind of already set it up here. This is a swag store. If you see us at any of the, like we did the AWS event recently, and we'll be at the KCD event next month, and we have a whole bunch of swag, and so you can go and pick yourself up a t-shirt there. And this is my nice React front end, And what I'm going to do, so all of these, I'm not going to bring up the network tab because I think it will be too small. But basically, when you load this page, it makes a network call to a backend and it pulls back all of the product data. We're going to make a change to the backend, and then we're going to be able to test that change on the front end here. And so what that's effectively doing is, like what I just described, is exactly what you can see there. The front end makes a request to products. We are going to steal that request, and we're actually going to serve it from our backend. So let's get started. So we're going to do install, and let's come over here, paste. I've already actually set this up, so I think it's just going to do nothing. Okay, cool, it works. So everyone, oh, this is too small. That's not doing what I thought it would do. Okay. It's too small to see from the back, isn't it? Yeah, it's not getting bigger. Okay. I just had to click a lot. That's good. All right, there we go. That's better. All right, so I've already run the first command here. This is just installing the companion app. And really all we're doing in the second step here as well is we're installing the Mirror-D binary, right? So Mirror-D, we're using the CLI for this. We're installing the Mirror-D binary, and we're connecting to a remote Kubernetes cluster that I've got set up. So if for anyone who's actually participating on the laptop there, this manual side here kind of explains what's happening. You're going to claim a seat in that Kubernetes cluster, which basically just allows you to authenticate to your own personal namespace within that cluster. The interesting thing about Mirror-D is that it actually doesn't matter what language I've written that inventory service in the cluster. Because we're stealing the traffic and we're serving it from our local, you can actually, obviously you're not going to do this from a workplace perspective, but in this workshop, you can use any of these. I've had Claude rebuild my inventory service in all of these languages, so you can pick whichever language you'd like to use to run locally. And depending on which one you pick, you'll have to just download a couple of different files here. And then there's just a couple of CLI commands that we're going to run in order to see that working. Using the companion app, it's really just going to automate all these parts for us, and then we're just going to jump to the bottom here. So I am going to do this and paste it and click enter. Oh, okay. And that is too small. And so our little companion app here has actually opened up a Node.js version of the inventory service there. And coming back here, we can now run. It's given us effectively a list of commands for us to run. Now, is anyone like stuck in the process of the workshop? Because I imagine half of you have probably finished the workshop already, because unless you're jumping ahead of me, if you're not jumping ahead of me talking. Ooh, that's romantic. Oh, all right. So let's actually just go ahead and do this. This is a bit hard with the mic. I was going to do keyboard shortcuts. That's all right. Let's just do it like that. Okay, one. So first, I'm going into the directory where our code was created. Next, we created a kubeconfig file so that we can authenticate to the cluster. So I'm going to do that. Next, I'm going to run an npm install to install the dependencies. Then I'm going to run a kubectl get pods. Now, how many people here actually use Kubernetes? Okay, about half, yeah. So for anyone who doesn't use Kubernetes, pods in Kubernetes are effectively like the services that you're running. So you can see that I have a front-end service, which is like my React front-end, and then I've got a back-end inventory service here. And the fact that I was able to run that command and see that data means that I've authenticated to Kubernetes. Now I'm going to do this one, cat mirad.json. So nothing that we've actually seen so far is actually particularly like unique to Mirad, the tool, but this is where kind of the magic starts happening. So when you want to use Mirad, what you do is you create a mirad.json config file. And so what we're doing here is we're specifying like what is the target remote pod or container that we want to, say, copy the environment variables from, steal the network requests from, access the file system to. And so that's what we set as our target. Now, in a Kubernetes context, we're setting there a deployment can have many pods, and pods are sort of like instances of your service running. So in this instance, we're saying we want to target any of the pods within that particular deployment, the inventory service. Then just below that, what we're saying is for incoming network traffic, we're going to start steal mode. And so we actually want to steal the requests. There are other modes. So example, mirror mode would just get a copy of the request, but the actual real service would still provide a response to upstream services. Whereas in steal mode, we're actually stealing the request. The remote service doesn't receive the request at all. We're also saying that we only want to steal the product's endpoint. Normally, you wouldn't do that, but for the purpose of this demo, I didn't really want your laptop to get all the health checks that were going against that pod. And so we've just added a filter there to only get the product's endpoint. For outgoing network requests, we're saying that we want those to go out through the pod that we're targeting. And we also want to do DNS resolution in the pod that we're targeting. So that means we can actually talk to internal Kubernetes services from our local machine. We're also saying pull in all the environment variables. For file system, we actually want to just keep it local, and host name false. I can't actually remember what that one does. Cool, so that's our Mirad config file. And then the last piece de resistance. Okay, I need two hands. So in order to actually start Mirad, the only thing we really needed to do, this is a little bit more complicated than it needed to be, we just needed the node and then the server.js with the Mirad exec at the front. So you basically do Mirad exec, pass in the config file, and then the hyphen, and then node server.js. I've just added in this reload thing so that we get nice hot reloading for the demo. So I'm going to paste that, run it there. You can see that it's starting up using Mirad. So the Mirad part has now started, and we are up and running. All right, so let's have a look. Now, interestingly, and I haven't got this in a diagram, but what you can probably see in the code here is that we are actually connecting to the Postgres database that's running in the cluster. So I've actually spun up a Postgres database as a pod in the cluster, but because all of our network requests, because basically we have all the environment variables from the pod which injected the database credentials and the DNS, and when we make network requests out, it's going out through the pod. We actually have connectivity to our database. If this was like an AWS RDS or in GCP, and if that authentication usually happens via IAM auth, that will just work seamlessly as well, because all the network requests coming from your local process are actually going out through the remote pod. And it'll just work seamlessly. Okay, so now what I can do, I am running. So I think you can see there it says, the front end is showing products from the back end pod in the cluster, so on and so forth. But I'm going to refresh the page, and ta-da, we're now served by my local MacBook. You're stealing the back end. Oh, and I've already added the prefix there. So in the code for each of the different programming languages, you'll see that there's a place there to set a prefix, and it says edit me. And I've already added my local there. And so we've actually changed the response that was coming back from the back end, and we've added my local to the product names of all of the different products. And so what this allows you to do is, like, you know, in a more complex environment, you can start like a back-end service, run it using Mirror-D, and then like see how that affects like the rest of the environment, but without actually deploying to that environment. And if you're setting the right HTTP filters, so for example, I've just got this one here, but for most of our bigger customers, like if you're setting the right filters, you can basically set this up so that everyone can start Mirror-D sessions at the same time on the same services. They're only stealing their own requests. They're not stealing other people's requests. You can basically have like an infinite number of people concurrently testing against the same test environment, but without breaking that test environment. And yeah, ultimately, like, yeah, if your CI/CD normally takes 20 minutes to deploy and you've got to go find a test environment that's working, and you have to wait 20 minutes to test out your change here, like using Mirror-D, you can just do it instantly from your local. That was really all I was going to cover today. Thank you. But I'll take, let's do applause and then I'll take some questions. Round of applause. Ah, very good. Any questions? Yes.
So your production app needs to be running on the Kubernetes. That would be the prerequisite. You can't have your application running in an isolated container. And
Yep.
you try to simulate testing via Kubernetes.
Yes. So the way that it works right now is it's a Kubernetes native solution at the moment. And so you do need to be running in Kubernetes, and we're actually leveraging a couple of the, we're leveraging like the architecture of Kubernetes to do everything. We are in the process of building what's called Mirror-D, Mirror-D Anywhere. That will allow Mirror-D to work in any containerized environment. So that is not available yet. Right now it's Kubernetes only. The timeline is sort of end of July, beginning of August. We'll have Mirror-D Anywhere, and then it'll work for like ECS or serverless, basically any containerized code. Yep.
How is it different than traffic shadowing? Like we can do traffic shadowing where it can send a percentage of requests to a different upstream. How is this different? Obviously you're sending it to the local. But I just want to say, how is it different than, let's say, traffic shadowing that you can probably do at the API?
So is that like if you're doing A/B testing, where you're sending like some requests to one service, and then like as you deploy, maybe you're sending a percentage of requests to other services?
Well, on the API gateway, for example, you can do something called as traffic shadowing, where you can send a percentage of requests to a different, like a shadow or a canary sort of service. I get that you're kind of sending it to the local in case of Mirror-D. Just wanted to understand, the contrast between the two.
So with what you're describing, like I think the use case is not so much like local development, and you're not going to speed up like your local development by doing that. That would be more of like a testing, like being able to test a change in production, probably in a way that if it is broken, it's not going to break for everyone. It's going to break for like a small percentage of users. The use case for Mirror-D is very much like speeding up your development cycle. And so I guess the ability to make a change on your local machine and then instantly see how that change performs like in that remote test environment. You're typically just testing it yourself. You're not trying to partition off like a small subset of traffic or anything like that. But I think the main difference is just like the intent of.
So this is more from an app developer perspective?
This is very much for app development and like developer productivity, developer experience, that side of things. It's not like a launch darkly type or which solution. It's not like that.
So traffic shadowing would be more on the platform team's use case, and this is more on the app developer.
I think, yeah. So in the paid edition, there is this idea of preview environments, which might be similar to that. So the idea of preview environments would be where in this diagram here with a preview environment, rather than starting the service on your laptop, what we actually do is start the service here, like next to this inventory service, and then we give you like a special URL or some HTTP header, and you kind of go in through the normal front end. But if you're using a special header or your special URL, it'll actually, the front end will call this, preview version of the inventory service rather than this one. Whereas if you're using like the normal URL, you call that one. That's like more of the use case that we see platform teams and like QA teams getting interested in, is like the preview environment side. But from an open source perspective, it's very much just about like developer productivity and experience. Yeah?
So this would it work for you running locally with like breakpoints in the parts of the code?
Yep. So I didn't use the IDE extensions. So the IDE extensions we have right now are any VS Code and like fork of VS Code, like all of the AI IDEs and any of the JetBrains IDEs. And so if you're using our IDE extension, then yeah, you can very easily like set breakpoints. If you're doing like if you've got a breakpoint solution that you can start from the CLI, then you can definitely use us to do that as well. Yep. Yes?
So, just for my sense, just to clarify, what it's doing is it's replacing the JavaScript component with whatever the application bundle is on the Kubernetes cluster. Is that
No.
locally driven container?
And I probably should have, I think at one point I had a slide, but I took it out, but I probably should have explained it. So what it actually does is it hooks into the system calls that your local process is making on your local machine. So when your local machine like tries to make a network call at the operating system level, Mirror-D actually intercepts the call, and rather than making the network call, it actually redirects the network call back into we call it an agent, but it's the old-fashioned usage of the word agent. It is not an AI agent. We actually redirect it back into like an agent running in the cluster, and we make the network call from within the cluster.
So follow-up question, how does it differ from, say, like using Charles or something like that?
So Charles would only do the networking aspect of this, and Charles would also only do outgoing network requests. So this, not only are you making network requests from your local machine and then sending them out via the cluster, but we're also stealing requests intended for containers running in the cluster and redirecting those down to our local machine. And then there's like the environment variable side, and there's the file system side as well. So it's really working by intercepting the operating system calls that this process is making, and also some of the things that this process is doing in order to steal requests in order to work. But yeah, we're not actually deploying this code into the cluster at all. It is all happening on our local machine. I didn't see who was first. Yes?
Yeah, so you said that you are requesting the call from a cluster. So does that mean there has to be more than one pod running within the cluster?
No.
Confused because I started just learning just now. I was confused, you are getting a different URL when you are using Mirror-D.
This is actually this would actually be just if you're starting like a HTTP service, like I am here. This one, I would actually be able to talk to this service on localhost. Like I could just ping my service on localhost 8080. I can probably do it. Oh, it's super small. Oh. No, it's not working. Was it 8080? It was 8080. Anyway, that's what happens when you try and do a live demo and try something. Yeah, like I can hit my service on 8080. So it is running on my machine. And if I was like doing the front end version of this testing, then I would probably just use localhost and I'd just be connecting to all the back end services that were running in the cluster. But because I was testing a back end, it makes more sense to use the back end that's running in the cluster, and then that goes and makes a request down into my local machine. Did I answer the question? Sort of?
No, I'm not comfortable with Kubernetes. I just, yeah.
Oh, okay. It's more of a Kubernetes question.
I might be wrong because I was thinking, because I think Kubernetes, different pods could have a different version of the software, right?
Yes, that's correct.
Yeah, so I'm just wondering, because you're making changes in the software and you're rerouting that request from Kubernetes to your local host,
Yes.
does that mean it has to be multi-pod Kubernetes?
No.
I don't know Kubernetes much.
So we're just basically stealing the request that was intended for the pod in Kubernetes and serving that request from our local machine.
Then how do you deploy that? Like in that pod, like it's a single pod running within Kubernetes?
Okay, so I guess maybe the answer to that is we do need to have, well, we don't need it, but in this example, we did need to have two pods. Like I needed to have a front-end pod making a request to a back-end pod to kind of demonstrate that, like that stealing ability. So if I only had like one pod, which had the back-end and front-end in the one pod, then I wouldn't have the ability to like intercept the request between the two, and I wouldn't be able to like demonstrate the stealing capacity. But in terms of like this pod here, I could have one pod or I could have 10 pods of this inventory service, but I would just be stealing the requests that were going into, it depends if I'm targeting all of the pods in a deployment or if I'm targeting just a single specific pod within that deployment. And that would basically dictate whether or not I'm stealing those requests.
I think to answer your question, it doesn't need to have 2 or 3 replicas of in the deployment, like in Kubernetes, how you have your deployments, the replicas. You don't need to have that. It could just be one, or it could be many as well. Doesn't matter. You're just gonna route it to the.
Yep.
And that curl request that you tried is actually working on mine.
Oh, very good. Actually, I should have asked, like, did anyone do the workshop and then it didn't work? Oh, that worked. Okay, one. Did anyone else get it working? One. Hands up. Anyone else get it working? Oh, anyone. Oh, no. Did it break for anyone else?
So I've used MirrorD outside of this workshop and it does work.
I was confident of MirrorD working. I wasn't as confident of just like my workshop working. But I had one. Yes?
You mentioned about the testing and how it reduces the cycle of this. Can there be a use case where you or anyone has tried to use it as a service virtualization?
As a service what, sorry?
Service virtualization. So let's say we don't have enough environments for our clients to use it. Maybe with this solution, can that problem be solved? Wherein it acts as a service virtualization, reflecting our exact code which is there in the functional, but the client accesses it rather than their local. So without us picking up the specific environment for the clients, can this serve at I'm just wondering, has anyone tried using this?
Possibly. Like, I think the devil would be in the detail. We definitely have customers who come up with, oh, there's fireworks. There's definitely customers who come up with interesting use cases. So some examples would be clients use it, they start Postman with MirrorD, and then you can you can basically just run queries against like Kubernetes services using Postman on your local to do stuff like that. So starting like third-party applications. We have customers, although we wouldn't recommend this, we have customers who like use us to debug production issues where like rather than stealing a request, you do a mirror of a request and then you're basically like mirroring some production traffic down onto your local, and you can like set a breakpoint and debug. This would be if like you didn't have enough logging on your production and you had no way to increase the amount of logging or something like that. It's not what we recommend, but like I know that we have people doing that. As to like your exact use case, I would have to think about it a bit more. Yep. Yes.
How useful would be in a scenario where right now you showed us on the Kubernetes side, but what if we are running AWS services?
Yep. Like ECS. Yeah, so ECS support's coming in like 2 months, 1 to 2 months. So right now we just don't support like other containerized solutions, but we will in a couple of months.
But then how useful would it be? Because in your example, I saw that you were using connection to the database. What if you don't have permissions to connect to the database or other services on AWS, but you could?
So the way that that's going to work, there's a lot of fireworks. Maybe it must be because it was my talk. So with like any like permissions, like IAM permissions as an example, they typically work seamlessly because like often the way that works is like AWS injects some secret into the container, and then it also relies on like the, let's call it the network location of the container to do a whole bunch of other verification. And so the environment variable injected into the container is going to be copied by Mira D and sent down to your local, so you'll have that environment variable. And then the actual network request that is made by your local process with that environment variable to like authenticate the service to, say, that database is actually routed back out through the original container. And so like all of the IAM auth that you need, like all of the different services that use IAM auth, it's typically like seamless. Like you can connect to all of them using the original container's IAM credentials, but from your local machine.
So is it listening on the container port?
It is not listening on the container port. So with the Mira D Anywhere solution, I'm not actually 100% sure how it's doing the request interception, but for the Kubernetes version, it's actually basically it's running like a sidecar container on the pod and then intercepting the network requests in like at the operating system and redirecting them down to your local.
Your local machine, right?
No, it does that on the remote. It does that on the remote side as well. So for Kubernetes, we're able to leverage like the Kubernetes architecture in such a way where you don't like your application can be like completely unaware of Mira D, and it works. For the Mira D Anywhere solution, I suspect you're going to have to add something to like your Docker file, which adds like a Mira D runtime in there, and that will allow us to do the network interception on the remote side. Yep. Yes?
Is this just for HTTP traffic?
No, it works with all TCP and UDP traffic. Yep. It's very impressive behind us.
I think the universe is trying to tell you something. Exploding drones.
Yeah. All right, last question, if there is any more, otherwise we will wrap it up. We will wrap it up. Thank you very much, everyone. Good evening.